Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating paper, Understanding the Basis of the Kalman Filter via a Simple and Intuitive Derivation. It's a classic piece, really helps demystify this powerful algorithm.
Right. I've always found Kalman filters a bit intimidating, all those matrices and equations. But a simple and intuitive derivation? That sounds promising. What's the core idea?
Exactly. The paper focuses on making the Kalman filter accessible. It cleverly breaks down the core concepts step by step, avoiding overwhelming the reader with complex math up front. It starts with the fundamental problem, estimating an unknown state based on noisy measurements, right?
Yes, that's the essence of it. So how does this derivation approach the problem differently? Does it use a specific technique?
It uses a really clever approach. Instead of jumping straight into the full Kalman filter equations, it builds up the solution incrementally. It starts with a simple case, then gradually adds complexity, showing how each component contributes to the overall solution. It's like building with Legos. You start with a simple structure and add pieces one by one.
I see. So it's a pedagogical approach, prioritizing understanding over immediate mathematical rigor? That's a great way to tackle a complex topic. Does it use any specific examples or analogies to illustrate the concepts?
Absolutely. It uses several analogies to make the concepts more intuitive. I think one of the most effective is the comparison to a simple averaging process. It shows how the Kalman filter is essentially a sophisticated weighted average, where the weights are determined by the uncertainty in the measurements and the model.
Interesting. So it's not just about the math, but also about the intuition behind the weighting scheme. That's crucial for understanding how the filter works. Does the paper delve into the practical applications of the Kalman filter? I mean, beyond the theoretical explanation?
Yes, it does touch upon applications, but mostly focuses on the core concepts. It hints at its use in various fields like navigation, tracking, and signal processing, but doesn't go into specific examples in detail. It's more of a foundational paper, setting the stage for deeper exploration.
That makes sense. A strong foundation is essential before diving into the specifics of applications. So overall, would you recommend this paper to someone looking to understand the Kalman filter?
Absolutely. It's a fantastic resource for anyone who wants to grasp the underlying principles without getting bogged down in the mathematical intricacies. The intuitive approach and clear explanations make it a truly valuable contribution to the literature. It's a great starting point, you know?
I agree. It sounds like a perfect blend of rigor and accessibility. Thanks for highlighting this paper. It's definitely going on my reading list.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll see you next time. Goodbye.
Bye-bye.